Wireless charging is a rapidly developing technology that avoids the inconveniences of using a power cord. Manufacturers are currently working on a wireless charging gadget since they believe the power connection is a critical flaw in mobile devices. In wireless charging technology, inductive coupling is utilized to transfer energy from electromagnetic fields to electrical equipment. The electrical devices use the transmitted power to charge the batteries. In this video, we will tell you how wireless chargers are going to change the EV world. But before that, don't forget to smash the like button, subscribe to the channel, and hit that bell button to be notified whenever we publish a new video. The globe is becoming increasingly wireless. Phones and the internet went wireless in a few decades, and now charging has gone wireless as well. Technology has found its way in creating many practical applications, from smartphones and laptops to wearables, household appliances, and even electric vehicles. There are various wireless charging solutions today designed to eliminate the need for cords. Wireless charging promises better mobility and advancements that could enable the Internet of Things, IoT devices, to be fueled from a distance. Which is why the automobile, healthcare, and manufacturing industries are progressively adopting the technology. Wireless charging technology. The eco-friendly rechargeable batteries used in wireless charging technology are more efficient than throwaway batteries and do not require replacement regularly. Furthermore, wireless electricity makes charging electric cars much more accessible and more straightforward. Wireless hubs for charging electric automobiles are currently being developed by companies such as Plugless Power and Wetraticity. Wireless hubs enable charging by simply parking electric cars with a magnetic resonant disc on an undercarriage over another disc on the ground. The Nexus 4 phone from Google supports wireless charging through the Wireless Power Consortium's Qi charging standard, allowing power transfer across distances of up to 40 mm. The phone is charged with a charging orb shaped like a sphere with a cross-portion cutout. The phone is positioned at an angle above the dock, allowing the phone's magnets and the dock's magnets to transfer energy to charge the battery. Global wireless charging market. By 2026, the global wireless charging market is expected to be valued at over $30 billion. It provides customers with the utmost convenience while also ensuring safe charging in dangerous areas where an electrical spark could cause an explosion. Because electromagnetic waves can transport energy and information, telecom companies could theoretically beam power around like kitten videos and music. However, there are numerous practical difficulties. Microwave beams, focused precisely on a receiver, are employed in most long-range power transfer studies. Think of charging a solar panel with a laser pointer, but this method does not scale well to millions of units. However, a different method makes universal wireless charging more possible at short distances. Like how screaming out the perfect pitch can break a wine glass, a magnetic field vibrating at one specific frequency can cause a surrounding magnetic area to wobble in response. How does it work? The magnetic resonance (MR) principle or inductive power transfer underpins wireless charging (IPT). Energy is transmitted from the charger to a receiver at the device's back using electromagnetic induction. Radio charging. Smartphones, wireless mice, wireless keyboards, medical equipment, smartwatches, music players, and other devices with small batteries and low power consumption are among the gadgets that benefit from this technology. The device's receiver is tuned to the same frequency as the transmitter, allowing it to charge through radio waves. Inductive charging. Medium-sized electronics such as cell phones, tablets, music players, and kitchen appliances are commonly charged via this approach. The gadget must be put on a wireless or conductive charging pad, which is then plugged into an electrical outlet for inductive charging to work. Resonance charging. Resonant wireless chargers are used to charge items that utilize a lot of energy, such as computers, electric cars, vacuum cleaners, and robots. The device's copper coil is set to the same electromagnetic frequency as the power source's coil in resonance charging. Standard wireless charging technologies. The two most prevalent wireless charging technologies are the Wireless Power Consortium (WPC) and the Power Matters Alliance (PMA). WPC and PMA are related technologies that operate on the same concept, but they differ in operation frequency and connection protocols. The WPC charging standard is a non-profit organization with an open membership that maintains many wireless charging standards, notably the Qi standard, the most widely used today. Apple, Samsung, Nokia, and HTC are among the smartphone companies that have adopted the standard. The Qi standard necessitates a physical connection between the source and the device being charged. The technique now allows for wireless power transfer of up to 5 watts across a distance of up to 5 millimeters at a frequency of 100 to 200 kHz. With further advancements, the technology will send up to 15 watts and then 120 watts over considerably long distances. The PMA technology uses the same electromagnetic induction concept as the Qi standard, but at twice the frequency. The technique initially allowed for power transfers of 3.5 and 6.5 watts. However, this has now been increased to 50 watts. Both the WPC and PMA standards cover inductive and resonant wireless charging technologies. Wireless chargers to change the EV world. Wireless charging in the future is projected to be based on dynamic electric vehicle charging (DEVC), which allows automobiles to be charged while they are still moving. This will undoubtedly boost travel because drivers will no longer have to wait in line for their cars to be charged. Also, because the vehicles will no longer require energy storage now. This DEVC technology reduces vehicle weight. The goal of wireless charging is to increase the range and mobility of device users. Previously, the technology only allowed you to charge your cell phone a few centimeters away from the charging equipment. That distance has recently been increased by a few centimeters, and if things continue in this direction, it may be possible to charge your devices over distances of several meters. Furthermore, new and creative wireless charging applications are being introduced by the commercial sector. Restaurant tables that can charge smartphones and other devices, office furniture with integrated charging capabilities, and kitchen countertops that can set coffee makers are just a few of the applications you may expect to see in the near future. Famous wireless charging. Starbucks plans to test 17 Duracell PowerMat charging stations in Boston area stores as part of its support for the PMA in creating wireless charging standards. Furthermore, numerous automakers are developing wireless charging technology for electric vehicles because plug-in charging is too complicated and could cause the batteries to charge while driving. Qualcomm's kit, based on wireless electric vehicle charging technology, is used in Delta's electric sports car. The car uses a vehicle-mounted pad linked to a Qualcomm-controlled unit, which is then connected to the battery. When the vehicle is aligned with a pad on the ground, a touchscreen interface alerts the driver to begin the process and updates the charging progress. Although wireless charging technology is already available for mobile phones and other gadgets, it will take years for this technology to become popular in moving automobiles. Wireless charging minimizes the number of natural resources and energy used in the manufacturing and packing of traditional chargers. It also cuts down on non-biodegradable and harmful waste produced by conventional chargers. Wireless charging technology is being used in several electric automobiles. The use of wireless electric car charging technology means that drivers charge their vehicles frequently and in a small amount of time. This technology allows for dynamic charging to accommodate local stationary chargers, removing the concern about range. Furthermore, due to the small size of batteries, the electric vehicle's weight and cost can be reduced. Amazing! What do you think about how wireless chargers are going to change the EV world? Have you ever thought about this the moment you heard about wireless chargers? Do you also charge your gadgets in wireless means? And also, what are your thoughts on this video? Feel free to drop your reviews and responses in the comment section below. And before leaving, don't forget to like, subscribe, and hit the bell button for notifications on our future content. See you in the next video.